Okay, so we're continuing the concept of row echelon form and reduced row echelon form on this video. Okay, so in this example it says write the solution represented by the augmented matrix. So it's telling me that it's augmented. Remember, that's what these colons mean. So I'm going to put in x's in this column, y's in this column. So now I can clearly see that the solution of x is equal to -3. And the solution for y is 5. So now I actually have a coordinate point for the solution of this system is -3, 5. And we need to know this concept here for something we're about to do in example coming up. Okay, so Gaussian elimination with back substitution. So what we're going to do is what we did in our last video. Remember how we put it in row echelon form? We got those ones, and then we got the zeros below the ones. But this time we're going to go one step further. We're going to use back substitution to determine the solution for x, y, z, where the system, or it could just be x, y, where the system intersects, where their solution is. So what we're going to do is we're going to write the augmented matrix, we're going to put it in row echelon form, and then we're going to back substitute. Alright, so here's an example. This one's just a 2-variable system. Do not use what we learned in Chapter 7 to solve this system. You actually need to use Gaussian elimination and want to see matrices. So what we're going to do is we're going to start by writing the matrix to the following. Alright, so here's our matrix. Remember, the first thing we want to do for row echelon form is make sure that we have a 1 in this position, and we do. So we don't have to switch anything, we don't have to divide by anything, we can leave it alone. The next thing I want to do is make sure that there's a 0 here. So what we learned yesterday is if we manipulate the row directly above it, if there's a 1 here, and multiply by the opposite sign and add it to it, then this term becomes a 0. So what I'm saying is take row 1, multiply it by the opposite value, and add it to the row we're trying to change. So let's go ahead and do that. So if I multiply row 1 by -2, I'm going to get -2, -4, -14. I'm adding that to 2, 1, and 8. Let's rewrite our matrix. Row 1 is staying, 1, 2, 7, and row 2 is going to become 0, -3, and -6. Okay, the next thing we need to do, make sure this is in row echelon form. If not, you're not going to get credit for it. So I need to make sure that this term is now 1. So I'm going to divide by -3. Or take row 2 and divide it by -1/3. So now let's rewrite it. We're going to get 1, 2, 7, 0, 1, and 2. Now I have a system that I can back substitute. Here I can rewrite this as y equals 2, and the top can be rewritten as x plus 2y equals 7, and now I can back substitute this here. 2 times 2 is 4, 7 minus 4 is 3, x equals 3. So now I have a solution to the system, and that is 3, 2. Alright, let's take a look at this example. This one has 3 variables, so this one can get a little tricky. Let's start by writing the matrix. So 3, -2, 1, 15, -1, 1, 2, -10, 1, -1, -4, 14. Okay. Remember that the first thing we want for row echelon form is to put a 1 in this position. Yes, you could divide by 3, but if you divide this entire row by 3, you end up with fractions here. I think it would be easier just to swap these two rows together. So that's exactly what I'm going to do. I'm going to take row 1 and swap it with row 3. Alright, and the next thing I want to do is I want to go now to the second row. And I want to make this into 0. So remember, at this point, we look at the row above it that has a 1 in that position. If you multiply this row by the opposite number to this and add it to this row, you will end up with a 0 here. But conveniently, you don't have to multiply anything to row 1 because 1 plus -1 is 0. So that's going to help us out. So let's go ahead and just add row 1 and row 2 together. Alright, so let's go ahead. 1 plus -1 because I'm adding row 1 and row 2 to my new row. And I'm going to end up with 0, 0, -2, 4. And the bottom row we're not touching just yet, so that's 3, negative 2, 1, 15. And yes, it's okay to have this here. I just want to switch this now to a 1. So negative 2 divided by negative 2 becomes 1. So I'm going to take negative 1/2 of row 2. Let's go ahead and rewrite that. Alright, so let's take negative 1/2 of row 2. So that's going to be 0, 0, 1, negative 2. And row 1, row 3 I haven't touched, so that stays the same here. The next thing I want to do is now go down to row 3. Now, in order for this to fit the model, I need to just start by switching this to a 0. In order to switch this to 0, I need to go where there's a 1 in this position and multiply by the opposite sign. That brings me back to row 1. So I'm going to do row 1 times negative 3, add that to row 3, and let's see what we end up with. Alright, so when we multiply row 1 by negative 3, we end up with negative 3, 3, 12, and negative 42. And we're going to add that to row 3, which is 3, negative 2, 1, 15. Let's go ahead and add them and put them in this row. So we're going to end up with 0, 1, 13, and negative 27. Okay. And we're almost at row echelon form here. If these two rows, if we flip them, then we fit the diagonal for 1 and the 0 pattern that we need. So I'm going to go ahead and do that. Alright, so here's where I took row 2, row 3, swapped them, and now you can see my my row echelon form. So now I want to use back substitution. Remember, this column is x, this column is y, this column is z. So here I can clearly see that z equals negative 2. I'm going to go ahead and back substitute that into my other equations as well, but let's identify the second equation. Y plus 13z equals negative 27. So I'm going to plug in negative 2 to 13, and I'm going to get y minus 26 equals negative 27. Y equals negative 1. Now I'm going to back substitute those two into the top equation, and I'm going to get x minus y minus 4z equals 14. And I'm going to plug in my negative 2 and my negative 1. So let's go ahead and do that. So x plus 1 plus 8 equals 14. X plus 9 equals 14. And x equals 5. So now I have my solution. X equals 5. Y equals negative 1, z equals negative 2. Okay, so now we're going to do what we've been doing, but this time instead of stopping when we end up with row echelon form, we're going to go to reduced row echelon form. So that way it brings us back to the first example where we had x, we saw the solution what it was, y, we saw the solution and what it was. So we're going to do the similar steps, except towards the end, we're going to flip it. Let me show you an example. Okay, it says use Gauss-Jordan elimination. So the first thing I want to do is I want to start by writing a matrix. Negative 2, 6, negative 22, 1, 2, negative 9. Again, remember the first thing I want to do is put a 1 in this position. So I'm going to flip row 1 and row 2. The next thing I want to do is I want to get a 0 in this position. So I'm going to take row 1, the row directly above it, and I'm going to multiply it by the opposite number value that I have here. So that's going to be 2. So 2 times row 1, and I'm going to add that to row 2. So 2 times row 1 would be 2, 4, negative 18, and I'm adding it to the following. So let's go ahead, rewrite our matrix. Row 1 stays 1, 2, negative 9. This becomes 0, 10, negative 40. The next thing I want to do is I want a 1 in this position. So 10 divided by 10 would be 1. So I'm going to take a 10th of row 2. Let's rewrite our matrix. And we're going to get the following. 1, 2, negative 9, 0, 1, negative 4. Before we were stopping right here. Now we're adding an additional step. Here's our matrix. In order to put this into row echelon form, I need zeros in everything but the diagonals of 1 and numbers in this final column. So I want a 0 here. So this time, remember we were looking at the row above to manipulate the row below? We're going to reverse that. This is the row I want to keep. This is what I'm changing. So I'm going to now manipulate the row below and add it to the first row. Because if I add 0 to 1, it's going to stay 1, and that number's not going to switch. And remember, we want a 1 here. I want a 0 here. So if I multiply 1 by -2 and add it to this 2, it's going to become a 0, and it's not going to change this 1, and that's what I want. So what I'm telling you to do is take row 2, multiply it by the opposite number you want to switch, which is -2, and add it to the row you want to change. So I'm going to go ahead and do that. So -2 times row 2 is going to be 0, -2, 8. I'm adding it to 1, to -9, and now you can clearly see 0 plus 1, that's not changing our matrix. So let's go ahead and rewrite our new matrix. I'll put it over here in this corner. 1, 0, -1, 0, 1, -4. And now you can see that we are in reduced row echelon form, and this brings us back to example 1, where I said, what's the solution for x? Well, here it is. What's the solution for y? Well, here it is. X equals -1 from this row. Y equals -4 from this row. So the solution to this system is -1, -4. All right, let's do a 3-variable system now. Let's take this matrix and use Gauss-Jordan elimination. So remember, the first thing we want is a 1 in this position. We have that. Okay? The second thing I want is a 0 in this position, so I'm going to add row 1 and row 2 together. So let's go ahead and do that. So row 1 stays. When I add row 1 to row 2, I get 0, 1, 3, and 5. And now on the bottom row, I'm going to have 2, -5, 5, 17. The next thing I want is I want a 0 in this position. I would want a 1 in this position. It's already there, so I can skip down here. I want a 0 here, so I'm going to multiply row 1 by -2 and add that to row 3. So let's go ahead and do that. All right, so let's take a look. I multiplied row 1 by -2. I got this. Row 3 is here. I'm going to add these two together, and I'm going to put in the bottom of this matrix, and I'm going to get 0, -1, -1, -1. The next thing I want is a 0 in this position. So if I add these two rows together, row 2 plus row 3, I'm going to get a 0 in this position, and that's what I want. So let's go ahead. We're adding again row 2, row 3. 0 plus 0, 0, 1 plus -1, 0, 3 minus 1, 2, 5 minus 1, 4. So we're almost at row echelon form. The next thing I need to do is change this to a 1. So if I divide row 3 by 2, or take a half of row 3, I am going to get it into row echelon form. So let's go ahead and do that. So 1, -2, 3, 9, 0, 1, 3, 5, 0, 0, 1, 2. Now I'm going to get it into reduced row echelon form, so let's go ahead and do that. All right, so what I'm going to do is now I'm going to go backwards. So this row is good to go. We have a 0, 0, 1. I know z equals 2. Now I want a 0 in this position so I can figure out what y is. So I'm going to manipulate row 3 and multiply it by the opposite sign here. So row 3 times -3, add that to row 2. All right, so let's take a look. I did -3 to row 3, and I got these solutions. This is my row 2. I'm going to add these two together to get my new row 2. So 0 plus 0, 0, 0 plus 1, 1, -3 plus 3, 0, -6 plus 5, -1. Now I know the solution of y. And now I'm going to do something similar here. I'm going to manipulate row 2 so that I get a 0 in this position. Okay? Or I can even get a, I'm sorry, pointed at the wrong one. I want a 0 in this position, so I need to manipulate row 3. So we're going to multiply row 3 by -3. Add that to row 1. Then we're going to multiply, let's see where we end up in row 2. Alright, so what I did here was I took -3 times row 3 and I got these solutions. 0, 0, -3, -6. Row 1, I just duplicated it here, and now I'm going to add them to get my new row 1, and I'm going to get the following. I get 1, -2, 0, 3. Now I just have one more number to switch to a 0. So because there's a 1 in this position, I'm going to multiply row 2 by the opposite value I see here. So row 2, what we're going to do is we're going to multiply it by 2, and we're going to add that to row 1. That way, this 1 doesn't switch, this 0 doesn't switch, and only this number here is switching. Alright, let's take a look. So 2 times row 2, 0, 2, 0, -2. And then plus row 1, so I duplicated row 1 here. Now I'm going to add these cells together, and I'm going to put the solution in here. So 0 plus 1, 1, 2 plus -2, 0, 0 plus 0, 0, -2 plus 3, 1. Now I have my solutions. Okay, my solutions are as follows. Remember, this column is x, this column is y, this column is z. So here I can clearly see x equals 1, y equals -1, z equals -2. So I can go ahead and put it as a coordinate, 1, -1, 2.